All right, y'all. The last lesson of this unit is solving system of equations using matrices. Now, we talked a little bit about matrices back in chapter 1. We're going to start off with a matrix, matrix A. Matrix A is going to be the matrix 4, 3, -2, 1. That's matrix A. Now, we're going to come back to matrix A in just a little bit, but we're going to talk about some other stuff with matrices. One matrix I want to talk about is the identity matrix. The identity matrix is kind of a neat thing. The identity matrix is, if you had a 2 by 2 identity matrix, it would be 1, 0, 0, 1. Any identity matrix is always going to be square, 2 by 2 or 3 by 3 or 8 by 8 or whatever. Starting from the top left and going diagonal is going to be a diagonal 1. Everything else is 0. So for example, a 3 by 3 identity matrix would be 1, 1, 1. I got 0, 0, 0, 1, 0, 0, 0, 1. That is a 3 by 3 identity matrix. Now, here's what's neat about the identity matrix. If you have matrix A times the identity matrix, you will get, well, here's the thing. Pull out your calculator. If you haven't gotten your calculator yet, press pause and go get it. Otherwise, you got your calculator. Here it is here. We're going to input these. Ooh, I want blue. Input these values into the calculator. Oh, there we go. Look at that. So, first button I want you to press matrix. Matrix is second, and then it's right below the math key. So, second matrix. Now, we're going to edit matrix A. Matrix A. Now, matrix A is a 2 by 2 matrix, right? Here's our matrix. This is a 2 by 2. So press 2, enter, and it'll adjust the entries for you. And we're going to put in matrix A. So it'll be 4, enter, 3, -2, enter, 1. There's our matrix. All right. Now go back to matrix, and in matrix B, let's put in the identity matrix. So we're going to edit. Oops, my bad. I forgot. We're supposed to edit, then go down to matrix B. Matrix B is our 2 by 2 identity matrix. So 2, enter. We got 1, 0, 0, 1. All right. Now let's go back to our home screen. Now we're going to multiply matrix A times matrix I. So what we got here is go to matrix. Now this time, instead of editing, we're going to name matrix A times, now our matrix I, the identity matrix, was matrix B, remember. So number 2, matrix B. Matrix A times matrix B. Now we did this by hand before, but some of you are going to be unhappy to find out the calculator could have multiplied matrices for us. But matrix A times matrix B is 4, 3, -2, 1. Hey, that looks familiar, doesn't it? That is matrix A. The identity matrix is called the identity matrix because if you take a matrix and multiply it by the identity matrix, you'll get the original matrix back. It's like what 1 is to regular numbers. The identity matrix is to multiplication of matrices. Kind of neat, right? Sure. Another thing we need to talk about are what's called inverse matrices. Now, the way we say the inverse matrix, if this is matrix A, the inverse of matrix A is A to the, and it's got a little to the -1 up there. So there is a way to calculate this by hand, but let's just have our calculator do it for us. We still got our matrix A. So let's call up matrix A, but we want the inverse. No, we said that the inverse was like this to the -1 thing. That is the matrix button without hitting the second. So A to the -1 is gross 0.1, negative 0.3, 0.2, 0.4. So write that down. We got 0.1, negative 0.3, 0.2, and 0.4. Those are our inverse matrix A. That is the inverse of matrix A. Now, here's what's neat about matrix A and the inverse of matrix A. If we did matrix A times the inverse of matrix A, well, let's pull out our calculator. Let's try that. Oops. All right. Well, if we do the matrix A, second matrix A times the inverse of matrix A, so matrix A times matrix A, and then make the second one the inverse of matrix A, press enter. What do you think is going to happen? Take a guess. Let's see. Press enter, and what is that? That is the identity matrix. If we do matrix A times the inverse of matrix A, we will get the identity matrix. That's pretty crazy, huh? So, here's a big thing that I want to talk about today. If we have matrix A times matrix X, some X matrix is equal to B. If we want to solve what just happened? Whoa. I'm sorry, y'all. Some crazy stuff is happening here. I don't even know what's happening. Anyways, if we have matrix A times matrix X is equal to matrix B, we're going to solve for matrix X. Now, in order to get matrix A to go away, if this was an equation, we would divide by A, right? But with matrices, we never multiplied by matrices or divided by matrices. So instead, what we're going to do is we're going to multiply by the inverse of matrix A on both sides. But here's what's tricky about matrices. If we do a left side multiplication on this side, we have to do a left side multiplication on this side. Now, as we just saw, what is the inverse of matrix A times matrix A? Remember, up here it comes out the identity matrix. So what we have here now is this becomes the identity matrix times X equals, now this is going to be a left side multiplication, matrix inverse of matrix A times matrix B. Now, if you remember from up here, what happens if we do the identity matrix times a matrix? Well, identity times a matrix is the original matrix. So identity times matrix X is going to give us matrix X. Matrix X is equal to the inverse of matrix A times matrix B. What the crap just happened there, Smith? I don't even know what you're talking about. Here's the thing, y'all. Right now, this is the only thing that I need you to know. Matrix X is equal to the inverse of matrix A times B, matrix B. Smith, that didn't make it any better. I know. Let's do our first example. Example. 2x plus 5y equals negative 24. Then we got 3x minus 5y equals 14. Now, we could solve this by elimination. And some of you could do this in your head. The y's would cancel. You have 5x is equal to, you get, what was that, negative 10. So you get x is equal to negative 2. You plug that in, and I believe it's negative 4. But here's the thing. We're going to solve this a different way. We're going to solve this by using matrices. We're going to solve this by coming up with the equation matrix A times matrix X equals matrix B. Here we go. Matrix A is going to be 2, 5, 3, and negative 5. It's the coefficients of the X and Y's. All right, that's our matrix A. Matrix X. Now remember, this might be hard to remember. If you multiply a 2 by 2, matrix X has got to be a 2 by something. This is going to be a 2 by 1 matrix. Matrix X is going to be the variables, matrix X, or excuse me, X and Y. Matrix X is X and Y. Equals, now if you recall, when we multiply matrices 2 by 2 times a 2 by 1, our answer is going to be a 2 by 1. And our answer here equals, any guesses? Negative 24 and 14. That's our matrix B. Matrix A times matrix X is equal to matrix B. Now, holy shnikey, Smith, this seems complicated. Y'all, it's not. Here's what's up. Pull out your calculator. Clear everything out. We're going to go back to our matrices. We're going to put in matrix A and matrix B. So we're going to edit matrix A. It's still a 2 by 2. Only now it's different. 2, 5, 3, and negative 5. All right, so that's our matrix A. Go back to matrix B. We're going to edit matrix B. Now, matrix B is a 2 by 1. And our values are negative 24 and 14. All right, so then we quit. Now, if you recall, stop it. There we go. Up here we said that matrix X is equal to the inverse of matrix A times B, matrix B. So that's what we're going to put in. Put in matrix A, but we're doing the inverse of that, times matrix B, which is number 2. We got the point negative 2 and 4. Or in other words, matrix X, which is XY, is equal to negative 2, negative 4, which is the solution to this system. Our system, we take this matrix and make it an ordered pair. Negative 2, negative 4 is our solution to this system. All right, Smith, I kind of get it. Let's do one more. All right, but we're going to do a 3 by 3 system. X minus 2y minus z equals negative 1. Negative x plus 2y plus 4z equals negative 11. 2x plus y plus z equals 1. So this is a 3 by 3 system. If you recall from yesterday, this is kind of a pain in the butt to solve, right? By hand, you have to pick 2 of them, eliminate a variable, pick the third equation and another one, eliminate the same variable, solve the system, plug it back in to find the third variable, and then your final answer is an ordered triple, right? Here's the thing. Matrices make this a lot better. Matrix A times matrix X equals matrix B. Matrix A are the coefficients of our X, Y's, and Z's. So this is 1, negative 2, negative 1. Negative 1, 2, 4, 2, 1, 1. That's our matrix A. Times matrix X. X, Y, Z. Matrix X is always going to be stacked vertically like this. Equals, same thing with matrix B. Negative 1, negative 11, and 1. All right, so we set up our system. Now we let the calculator do all the work for us. Now here's the thing. We got to pick up our calculator. We got to edit our matrix A's and B's. Now A this time is a 3 by 3. So we got to put in some more stuff. Matrix B Well, you caught me in passing period. Matrix B is a